Hello students, welcome back. So now we are going to be focusing on bivariate analysis. The word bivariate means two variable. In this particular instance, we're going to be focusing on numerical versus numerical. So one variable is numerical and other variable is also numerical in value. So the first thing I'm doing, importing my necessary libraries, importing my pandas, also importing matplotlib and cbon. These are for your visualization purposes. So you can either load your pickle file that was saved in previous step, or you can actually read your CSV file. In this instance, I'm choosing to go with the CSV file. So first thing I'm doing, I'm printing my 10 samples. So I just want to see what type of values do I have in my column. So this kind of helps me identify my numerical columns. So when I print my first 10 samples, you can see that you have miles per gallon cylinder. So okay, this is a numerical. These are all numericals right here. All right. This is not numerical, this is not numerical. Now model year is saying 78, 76, 82. Although it is numerical in nature, but this is not technically numerical. Like you would not be like, this is more numerical in nature, like miles per gallon, displacement. So these are more numerical because these are continuous values. Okay, then you can also check for numerical columns using info command. So in this case, I'm saying df.info, memory uses deep, and that gives me which one of these numericals. So you can see that float 64. Anytime when you see columns that are like float or integer, generally they're indicator of numerical columns. So let's identify our numerical columns. The numerical columns that I'll be working with is MPG, displacement, horsepower, weight, and acceleration. Cylinder and model year, they are not true numerical values. They have a finite number of values. So they fall under categorical values. So I would not be using them as numerical columns. So let's start with scatter plot first. So the first thing I'm doing, I'm setting my palette and also setting my font for my title, labels, etc. And this particular syntax, that's what it does. This particular syntax, by the way, is optional. It's not necessary. I just want my colors to be gold, so I'm a gold kind of guy. So I just put gold over there, and I like my font size to be 14, my title size to be 18. So this is what I'm specifying over here. Again, this part is optional. Don't have to do this thing. You can go with the default. So let's do a simple plot. In this case, I want to do with MPG versus horsepower. So I specify my column equal to horsepower, and I'm calling scatter plot from cbon library. SNS is the alias for cbon library. Specify my data frame, specify your column, and my y-axis I want to be MPG. Also, I want my markers to be size 20. And then I'm putting a title, and then I'm doing plt.show. So this plots the graph or the scatter plot between MPG versus horsepower. And you can see that as your horsepower increases, your miles per gallon kind of like goes down. So the trend actually is like this. All right, that makes sense. When you have a high horsepower, your miles per gallon will go down. So the observation is this: the downward trend, it shows negative correlation. Higher horsepower means lower MPG. And now let's plot MPG versus rest of the columns. I want to plot MPG versus horsepower, MPG versus weight, MPG versus displacement, and MPG versus acceleration. I can actually do that individually, or I can actually create a for loop. So that's what I'm choosing. In this instance, I'm just using a for loop. So I'm going through each one of the columns, I'm iterating through each one of the columns, and I'm plotting scatter plot between MPG versus each one of these columns right here. And so when I plot this, you can see that, let's just scroll up a little bit over here and let's start with this one. So this is MPG versus horsepower, the one we did before. This is MPG versus weight. And you can see that as your weight increases, your MPG kind of like goes down, all right? What about displacement? Well, when your displacement is increasing from 100, 200, 300, you can see that your MPG has kind of like going down. It's showing like a downward trend. What about acceleration, MPG versus acceleration? Well, let's see. As your acceleration is increasing, your MPG is kind of like seems like it's going up, but it is not very strong positive relationship. You can see it goes up, but not it's not very strongly linear. So observation is this: that as your horsepower, weight, and your displacement increases, your MPG it decreases. On the other hand, there appears to be a weak relation between acceleration and MPG. And the weak relation is this: that is, as your acceleration increases, your MPG also kind of goes up somewhat. And now let's look at the correlation between the variables. So in this case, I want to look at the correlation between among all the variables: MPG, horsepower, weight, and acceleration. So in your data frame, there's an inbuilt method called core, which is a short for correlation. And that's going to print out your correlation matrix right here. So I print out the correlation matrix, and this is the numerical value. So let's read one of these values so it makes sense. So this one, let me just come over here. This one right here. This is telling me that the correlation between MPG and weight is minus 0.83. If you recall from your from your statistics class, that your correlation is always going to be between -1 to 0 to +1. So -1 means that if one goes up, the other one goes down perfectly. +1 means one goes up, the other one also goes up. But if you have 0, that means there's no correlation between two variables. So when you have minus 0.83, it is more in this direction over here. So that tells me that there is a very strong negative correlation between MPG and weight. So as your weight increases, your MPG actually goes, sorry, as your weight increases, your MPG goes down, or and vice versa. Let's look at this one right here. In this case, it's minus 0.417, and we saw that between weight and acceleration, there was not a very strong correlation between weight and acceleration. So that's why it's minus 0.41. So it's more closer to zero right here. But maybe you're not a number guy, maybe you're more like a visual guy, so you can you can actually use heat map to actually plot all these numbers on a heat map. That will give you more visual information. So in this case, I'm setting my figure size to be 7.5, and I'm using Seaborn library heat map inbuilt method. Supply your correlation matrix, that would be this matrix right here that you got from the step one, and then you specify annotation equal to true and specify these bunch of parameters right here. Okay, and then I'm also putting a title over here. So when I run this particular cell, it gives me this feature correlation heat map. So here you can see that your diagonal is all one. Let me decrease the size of the screen so this is more okay. You can see. All right, now if you look over here, this is a color bar right here. So anything that's this color, that would be closer to 1. Anything that's on this color, that will be closer to minus 0.5. In other words, it's going to be towards negative direction. So you can see that your red ones are all more closer to a positive correlation. So this is 0.86. So that tells me that the correlation between horsepower, let me just use the marker, the correlation between horsepower and weight is 0.86. Very strong correlation. So just by looking at the color, you can identify which one actually has a strong correlation. By the way, you can just focus only on the diagonals on this side. You don't have to do this one, because this one is mirror copy of this right here. Okay, this one layer, you can see that the correlation between miles per gallon acceleration is kind of like low, 0.42. The correlation between weight, but that with this right here, and MPG is very strong, minus 0.83. So when the weight increases, your MPG goes down. And now let's draw the trend plot between MPG and horsepower. So I specify my column equal to horsepower. In this instance, I'm calling Seaborn's library's reg plot, and this is an inbuilt method, and reg plot is short for regression plot. So specify your data frame, specify the column with your x-axis. In my case, in this particular instance, my x-axis is a horsepower. Specify your y-axis. In this case, is miles per gallon. So in this particular instance, your regression plot will show you your trend, and then you put your title and also put your just plt.show. When you run this, it's going to show you this graph right here. You can see it's going to show you all these dots and also this little line right here. This line tells you the trend line. This is called the trend line. Okay, so what do we observe? The trend line is basically has a downward trend. There's a negative correlation, and that makes sense because we saw that from the heat map, from the correlation matrix, that it was minus 0.78. So this right here is the indicator that it has a negative correlation. In other words, when you have a high horsepower, your lower would be your MPG. And now we do MPG versus rest of the column. So in this case, I'm doing MPG versus horsepower, MPG versus weight, MPG versus displacement, and MPG versus acceleration. So this is my columns right here, all of these columns. And in this case, I'm using for loop. I'm iterating through each one of the columns, and I'm actually plotting my reg plot against your column right here. And your Y would be your MPG. Or you can actually do individual cell. That should be fine too, because if you're not comfortable using for loop, you can do each one of these individually. Okay, so when I run this cell, and let me just decrease the size of the screen so it's a little bit more visible. And there you go. So when I run this cell, it shows me the distribution for the trend plot for each one of them. So you can see that MPG versus horsepower, the trend is going downward. We just saw that. This is MPG versus weight. So as your weight increases, your MPG actually kind of decreases. This is your trend line. And this is the trend line between MPG versus displacement. So as your displacement goes up, your MPG kind of goes down. All right. And this is MPG versus acceleration. In this case, it's showing that as your acceleration is going up, your MPG is kind of like going up somewhat. So the observation is this, that as your horsepower, weight, displacement increases, your MPG decreases. On the other hand, there appears to be a weak positive correlation between acceleration and MPG. And if you recall, it was only 0.42.